Hey, how you doing, Duff here? And we're going to be doing some attempts at practical 3D printing. So a couple weeks ago I lost this, and this is a rubber cap that's designed to go over the cotter pin and axle of my tractor. I have a Craftsman YT 4000 tractor, and I lost this, and this is like a dust cap basically to keep dirt and dust and sand and all kinds of shit out of there. So it's an important part, but I thought that would be cool. Even though I bought a replacement, I did buy a replacement, I thought it would be cool to see if I could print something that would work potentially out of TPU. I have my replacement part here, so I'm going to take some measurements, write those numbers down, try to design something in Tinkercad, and see how that goes. Alright, well, it looks like the battery on my digital calipers is dead. So I'm going to just try to do this manually using those measurements on the calipers. So I'm first going to get a diameter measurement here, measuring from the bottom because the top is squishy. So okay, so that looks like 40. Oh boy, it's tough in the eyes. That looks like 46 centimeters for the diameter. For the height, I'm going to try to. You probably can't see this on camera, but it kind of has like a cone end on it, so mine won't have that, but I'm just trying to account for that in my measurement here. So that's 46 and let's say 33. I did say I was going to write these down, didn't I? It's always good to like kind of draw a sketch of what you're doing, which I've seen echoed by a lot of people. So it's 46 millimeters across. Height, did I say that was? 33 millimeters high. And as far as the width, and I'm going to probably make it a little bit higher to give, well, yeah, let's make it 34, I guess. I want to give some room for the bottom. And as far as the width of the shell, it's not very wide. Again, I might go more wide with what I'm doing, but let's see. That's basic. It's basically a millimeter wide. So maybe I'll go, I don't know, maybe I'll go, well, it's a small piece, so it won't take long to print, so I think I'll go 2 millimeters for the width to start. And I can always revise that, but I like to have extra thickness for durability, if possible. So okay, there I have my base design. So now let's go into Tinkercad. Okay, so here we go. I am in Tinkercad. So we're going to start this design. I'm going to make it very simple. I'm not a great modeler, so we're going to start with the cylinder. Okay, and I said that cylinder needs to be 46 millimeters in diameter. So we're going to make that value 46. We're going to make this value 46. Okay. Then I also said that it needs to be 35 millimeters high. So let's get to the side. We're going to click this top value. Right now it defaults to 20. We're going to make that 35. Okay. So now I have a filled 35 millimeter cylinder. So now what I want to do is I want to bore this out. So what I need is let's see, I said I want a 2 millimeter wall, so I need a filled or a whole cylinder. So we're going to make that one. We're going to make that one. Okay, so it's 46 this one, so we want a 2 or a 3 millimeter wall. No, did I say 3? 2. Yeah, a 2 millimeter wall. So I need this one to be 44 in both direction. 44, 44, 44. And we're going to do the same height, even though there's one other thing we have to account for here. So 35 millimeters of height. Okay, so now what we want to do is we want to raise it off the ground. So I have a bottom. So that's 1 millimeter off. Okay, a 2 millimeter bottom we'll make it. We'll see how that goes. Right here's my value. Okay, so now I have my hole, which should fit inside of my solid cylinder. So now this is where you'll see how I'm not so great at Tinkercad. Let's see how I can get these aligned the best. So I if I have that one selected, the hole, and I shift click that, and I align them, and let's see if I align them like that, maybe? Align. Okay, so now they're aligned up and down. And now if I align again in the center, there we go. Okay. So now you see I have a solid bottom, and I should have an even 2 millimeter wall here around the top. So all I should have to do is group these, and to do that you can just draw a box around the things you want to group, and you hit the group, and now my cutout will be reflected on the screen. Okay, there we go. Bam. That looks kind of presentable, doesn't it? So this, like I said, this is not a perfect model, and I have no idea how it will actually fit, because there are some aspects to this that are a little bit different. It has like a little bulb around the middle, but we'll see. There's my model. I have it named wheel cover. I just need to export it as an STL, and we're going to save that folder. I try to keep my STLs organized as best as possible. Wheel cover for the tractor, save it. Okay, so there we have my model. So if I minimize that, I bring up Cura 3.31. Hopefully that's still recording. All right, let's change it to the Ender 2. That is my best printer for printing flexible. Actually, it really is the only one I've been successful with. So we got the Ender set up here, and we need to import that file that we just made. Look, it's been 30 seconds. I already forgot where it was. Tractor, wheel cover. Okay, there we go. All right, there it is on the Ender. So let me just review my settings on the Ender. I think what it's at should work. 20% infill. Oh no, well we want 100% infill for maximum strength on this for sure. Whoops, not 1,000, 100. 20 millimeters a second is my normal speed on this. 230 is what I print at. I don't know why these are different. Okay, 230, a 60-degree build plate has been working for me. And like I do a skirt, yeah, there's a little skirt, so I get the filament flowing. Let's do one more skirt line count. 3 skirts. All right, and this says 2 hours and 7 minutes. So let me go get my USB stick or SD card. Okay, I have my micro SD card. We're going to save. Insert the SD card the right way instead of upside down and crooked like a dumbass. All right, there you go. Okay, so that's my L drive, and we're gonna name this track hub cover. All right, we're gonna save it to my J drive. Okay, so now at that point we are done on the PC. Okay, unfortunately with the angle of the screen you probably can't see it, but it doesn't really matter because you can do this on any printer. So we are going to be printing from SD, and like I said, you can't see it. We're going to find that file. Actually, it probably should be on the first page. Okay, and there it is. Track hub cover. And you still can't see it. Track hub cover. So I have it loaded on the SD card. We're going to select it, and it's going to heat the bed to 60 degrees Celsius and get started. And according to Cura, this will take between 2 and 3 hours. So we'll report back and see how this goes. Cross your fingers. Alright, so here is the tractor. It's now the weekend. Here is my 3D printed cover made out of TPU. And when I press fit this on, it does fit. And here's the actual one that I bought, the replacement. So that does actually fit. It's probably a little loose. I think if I was to reprint this, I would make the walls maybe double the thickness to firm that up a little bit. But yeah, that does fit. That would work with a little modification. So that's kind of cool. Nice. All right, so that walks you through the process from the design to the modeling to creation to test fit of my axle cap. I may redesign this and make the walls a little bit thicker so it's a tighter fit, but for now I put the actual cap on just to make sure that it stays nice and tight. But yeah, good little project. So just a very simplistic example of what can be done with a little bit of effort. So that's all I have for you for now. If you found this video interesting, please give it a big thumbs up. If this is your first time visiting the channel, please consider subscribing. And that's all I got for you for now. Feel free to comment, ask questions, suggestions below. That's it for now. Till next time, Duffman out.